Edge computing can be a very powerful tool in wireless sensing, but it takes great insight and experience to really make it work well. And Phase 4 has been doing this for a long time, and let me explain the unique approach that we've taken to edge computing. First, let's talk about the data that a wireless sensor produces. A big term you hear a lot is big data. And we've taken a strong position at Phase 4 that we are not advocates of generating lots and lots of data. And that's for several reasons. First of all, to be very practical, nobody's going to look at it. Second is with a wireless sensor, when you're transmitting lots and lots and lots of data over the air and you've got your radio transmitter turned on all the time, you're going to burn through a lot of battery power and you're going to be replacing that battery every few months. Most of our wireless sensors, when we leverage edge computing, the batteries will last for many years. The other reason that we believe in small, actionable data that comes from edge computing is that in most industrial applications, our end users are just looking for a tip-off that something has changed in their process, that something is different or something is wrong, or that the motor is shaking more than it used to be, or the motor is drawing more current than it used to. And by sending a person out to look at that piece of equipment, they can typically find and solve the problem quickly before there's any downtime with small, actionable data. Edge computing can be very powerful on a wireless sensor, and let me give you some examples. There are some cases in monitoring a process or sensing something where a high sample rate is needed. For example, the most common high sample rate application is vibration. Monitoring the vibration in a machine can be a very effective way to predict an impending failure. Other examples that we've done with edge computing are monitoring a blinking light. Also, we have monitored audible noises like alarms. And in those situations, you can't just take one sample and know whether it's working properly or not. For example, our vibration motor monitoring sensor. Inside of here is a 3-axis accelerometer and a microprocessor. This microprocessor samples G-force, or the vibration or the movement of this sensor at 5 kilohertz. And it does that for 3 seconds. And it does it on 3 axes. That's generating a lot of data. 5,000 times 3 times 3 data points. Now, rather than trying to send that huge amount of data over the air to somebody that's never going to look at it, we've applied the most advanced research in vibration monitoring on rotating equipment to break that data down into 6 data points, into acceleration data, velocity data in both the rotational direction and the axial direction. And the research has shown that those 6 data points can be highly effective in tipping off a change in the process or in the machine that might predict impending failure. So instead of that huge amount of data, we send 6 highly effective, actionable, small data points.